Hey everyone, how you guys doing today? We're moving on. So that's chapter 15, classes and methods. So I hope we're gonna get into what I showcased in the last video. Let's see. Class and methods. Python is an object-oriented language. That is, it provides features that support object-oriented programming, which has these defining characteristics. Most of the computation expressed in terms of operation on objects. Objects often represent things in the real world, and methods often correspond to the way things in the real world interact. Programs include class and method definitions. For example, in the previous chapter, we defined a time class that corresponds to the way people record the time of day, and we defined functions that correspond to the kinds of things people do with time. But there's no explicit connection between the definition of the time class and the function definitions that follow. We can make that connection explicitly by rewriting a function as a method, which is defined inside a class definition. In the previous chapter, we defined a class named time. That's this one. And yeah, basically all you have to do is write that function within the class and pass itself. And then it's a method of the class or a function provided by that class. To make print time a method, all we have to do is move the function definition inside the class definition. Notice the change in indentation. At the same time, we'll change the name of the parameter from time to self. This change is not necessary, but it is conventional for the first parameter of a method to be named self. Yeah. To call this method, you have to pass a time object as an argument. Here's the function we'll use to make a time object. Okay, so that's actually a neat way to explain the whole class instance thing that I was saying, right? Where self is usually the first object in a function, and essentially that self is the instance of the class. So if you had defined this function outside, like here, and passed the instance of the class to the function, similarly, that's what happens when you put it inside the function, except it just happens automatically, right? If you call that method from an instance of a class. To call this method, you have to pass the time object as an argument. Here's a function we'll use to make a time object. Boom. And here's a time instance. Start make time 9:40. Now that there are two ways to call print time, the first and less common way is to use function syntax. In this version, time is the name of the class. Print time is the name of the method, and start is passed as a parameter. The second and more idiomatic way is to use the method syntax, right? So basically, yeah, you can essentially call the class method and actively pass the instance you care about, or you can just call it from the method itself and it is inherently automatically passed. In this version, start is the object method is invoked on, which is called the receiver, based on the analogy that invoking a method is like sending a message to an object. Regardless of the syntax, the behavior of the method is the same. The receiver is assigned the first parameter, so inside the method, self refers to the same object as start. Here's the time to int function from the previous chapter, and here's a version rewritten as a method. The first line uses the special command add method to time, which adds a method to a previously defined class. This command works in a Jupyter notebook, but it is not part of Python, so it won't work in other environments. Normally, all methods of a class are inside the class definition, so they get defined at the same time as the class. But for this book, it is helpful to define one method at a time. As in the previous example, the method definition is indented and the name of the parameter is self. Other than that, the method is identical to the function, and here's how we invoke it. Start.time to int. Boom, done. Easy peasy. It is common to say that we call a function and invoke a method, but they mean the same thing. Yeah, they do. I've honestly, like, this whole thing about methods is a bit like, it's good to have these terms and the glossary and like know that this is what it is, but I feel like this is a bit too specific with the terms, and it's good to know, but it's also good to know what it actually means, right? Because then whether someone says call a function or invoke the method, that you know what they're actually trying to say, right? Because it's not like everyone is perfect about formalizing this kind of terminology, right? And especially with arbitrary distinction between methods and invocation and all that jazz. It is common to say that we call okay, yeah, static methods. As another example, let's consider the int2time function. Here's a version from the previous chapter, def int2time seconds. Minute, second, and blah, 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 blah. This function takes seconds as a parameter and returns a new time object. If we transform it into a method of the time class, we have to invoke it on a time object. But if you're trying to create a new time object, what are we supposed to invoke it on? We can solve this chicken and egg problem using a static method, which the method does not require an instance of the class to be invoked. Here's how we rewrite the function as a static method. Because it is static, it does not have a self as a parameter. To invoke it, we use time, which is the class object. Start equals attribute error time. Type object has no attribute int2time. The result is a new object that represents 940. Oh wait, I didn't run this. There you go, that's why. Start.print time 940. Def make time. Okay, yeah, so because make time is, they haven't introduced under init yet. So make time is essentially how you instantiate the class. Add method to time, into time. We did all this. Now that we have time dot from seconds, we can use it to write add time as a method. Here's a function from the previous chapter, add time. And then we can add method to time, add time, blah, blah, blah. Boom, done. Very simple. Add time has self as a parameter because it is not a static method. It is an ordinary method, also called an instance method. To invoke it, we need a time instance. End equals start.add time, blah, blah, blah. Comparing time objects. As one more example, let's write is after as a method. Here's the is after function, which is a solution to an exercise in the previous chapter. Boom, boom. And then we can just add that as a method. Because we're now comparing two objects and the first parameter is self, we'll call the second parameter other. To use this method, we have to invoke it on one object and pass the other as an argument, and that is after start. One nice thing about the syntax is that almost reads like a question. End is after start. Question. The string method. When you write a method, you can choose almost any name you want. However, some names have special meanings. For example, if an object has a method named stir or dunderstir, Python uses that method to convert the object to a string. For example, here is a dunderstir method for a time object. This method is similar to print time from the previous chapter, except that it returns a string rather than printing it. You can invoke this method in the usual way, n.stir, but Python can also invoke it for you. If you use a built-in function stir to convert time object to a string, Python uses the dunderstir method in the time class. And it does the same if you print a time object. Methods like dunderstir are called special methods. You can identify them because their names begin and end with 2 underscores. The init method. The most special of special methods is dunder init, so called because it initializes the attributes of a new object. And dunder init method for the time class might look like this. Def dunder init blah. Now we instantiate a time object. Python invokes dunder init and passes along the arguments. So we can create an object and initialize the attributes at the same time. Boom, boom. Time takes no arguments. Okay, let me add that first, then do this. This is exactly what I was saying earlier with the dunder init. In this example, the parameters are optional. So if you call time with no arguments, you get the default values. Time equals time in time. If you provide one argument, it overrides hour. If you provide 2 arguments, they override hour and minute. And if you provide 3 arguments, they override all 3 default values. When I write a new class, almost always start by writing dunder init, which makes it easier to create objects, and dunderstir, which is useful for debugging. Operator overloading. By defining other special methods, you can specify the behavior of operators on programmer-defined types. For example, if you define a method named dunderadd for the time class, you can use the plus operator on time objects. Here's an add method. Operator overloading. By defining other special methods, you can specify the behavior of operations. For example, if you define, you can use plus operator on time objects. Yeah, so I had alluded to this earlier, like many videos ago in one of the earlier chapters, where essentially there are these magic functions where if you define them within a class, you can use these standard Python operators, like the way string plus string works, as well as some numeric type plus some numeric type. That's because the class that creates the string object and the class that also creates the int object, right? Because int is a class as well. It's a class and a type. It's a whole thing. The object itself is, if you define a method name add, the object itself can then use those operators. That's what these special functions do. And there's like less than, greater than, equals. So if you didn't add the underscore lt underscore, you can't use the less than or greater than operator. But if you add underscore add underscore, then you can use the plus operator at least. So that's nice. And you don't always want that functionality, obviously, but when it is possible, you can. It's totally fine. We can use it like this: duration equals time 1,32. There's a lot happening when we run these 3 lines of code. When we instantiate a time object, the dunder init method is invoked. When we use the plus operator with the time objects, it's the dunder add method that's invoked. And when we print a time object, its stir method is invoked. Changing the behavior of an operator so that it works like a programmer-defined types is called operator overloading. For every operator like plus, there is a corresponding special method like add, as I just gave some examples of, like with underscore. I think it's underscore lt. All dunder methods in Python. Yeah, let me just Google that. There must be a T. Every dunder. Let's check this guy out. That's why it took me so long during when I finally finished compiling the table of all of them. 100 dunder methods in Python. And I should have said that Python docs don't show such a single list rubber. Oh, table. Okay. I'm just curious. Init repr EQ. Quality and hashability. EQ NE hash. Returns typically bool. Orderability LT GT LEGE. Type conversions and string formatting. So underscore stir, underscore bool, int, float, bytes, complex, formats, repr. So repr is weird, but I'm not going to get into that. Context managers, enter and exit. Exe type, exe traceback. Containers and collections, len, iter, get item, set item, del item, contains, refers, next, missing. I don't know what missing does. This is actually a really nice. What the hell is Python morsels? Running efficiently requires planning a path of screencast for people who don't like screencasts. Okay, anyways, I'm not going to get into that, but I am going to save this as a tab group because this is a really nice page. I really like this. New tab group in this tab. Dunder methods cheat sheet is what I'm going to call that. Close this, go back. All right, going back to the chapter. Debugging. A time object is valid if the values of minute and second are between 0 and 60, including 0 but not 60, and if hour is positive, also hour and minute should be integer values, but we might allow second to have a fractional part. Requirements like these are called invariants because they should always be true. To put it in a different way, if they are not true, something has gone wrong. Running code to check invariants can help detect errors and find their causes. For example, you might have a method like isValid that takes a time object and returns false if it violates an invariant. Time object requirements like these are called invariants because they should always be true. To put it in a different way, they are not true, something has gone wrong. Time object is valid, our breaking is 60, and if hour is positive, also hour and minute should be integer values, but we might allow second to have a fraction part. Requirements like these are called invariants because fair enough. So any requirement that is true, no matter what, is an invariant. Yeah. Running code to check invariants can help detect errors and find their causes. For example, you might have a method like isValid that takes a time object and returns false, violates an invariant. And at the beginning of each method, you can check that the arguments make sure that they are valid, right? Self is not a valid time, self is not a valid time. Assert, self dot is valid, assert, blah, 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 blah. The assert statement evaluates the expression as follows. If the result is true, it does nothing. If the result is false, it causes an assertion error. Here's an example. Duration, time, minute, 132, print duration, except assertion error, start dot is after duration. So this is all good stuff, Ask a virtual difference. What's the difference between an instance method and a static method? Why are static methods called static? Exercises, write a definition for a date class that represents date. There's year, month, and day of the month. Write an init method that takes year, month, and day as parameters and assigns the parameters to attributes. Create an object that represents June 22nd, 1933. Write stir method. Write a method is after. Here's an exercise. Pretty good exercise. Totally agree. Totally should do it. This is what I was expecting the previous chapter to be, but it was not. Anyways, that's pretty simple, pretty straightforward. I rushed through this one a little bit because kind of the important points in this one I already brought up in the last one. Yeah, that's the end of the episode. Thank you guys for watching, and we are getting close to the end here. This is chapter 15. I think we only got a few more. Yeah, we have 16 and 17. I think I'll do 18 and 19 together. Because I don't think there's going to be anything specific in 19 to go over. So I'll probably do 18 and 19 together. And then I'll do also 16 and 17 remaining, then 18 and 19, and we can call it a day after that. Or call it a day on going through this book. What I'll do next is probably get back to the previous series of building apps with Fast API. Right, specifically at that point we'll probably look into the Graph API stuff because the WhatsApp integration is really important, and I've just been lazy about it. I took like a little mini vacation, and then it took me a little while to get back going again, but I think I'm back in full force now. So yeah, all right, thank you everyone for watching. Hope you have a great one. Bye bye.